Okay, so let's work on some examples out of 10.5. So the first one we have is this, and the instructions are to rationalize the denominator. So we want to make a fraction that doesn't have a square root on bottom. It may have a square root on top, but we don't want one on bottom. So if you've watched the videos for this section, then we're wanting to make the denominator a perfect square. And remember, if we have the same factor under a radical twice, that's equivalent to having that squared. And if we have a square under a square root, then that factor comes out. Anytime we have the same factor 2 times under a square root, we can bring that number out. So if we have a 7 underneath the radical, we only have one 7, so we need another 7 under the square root to make this a perfect square. But if we multiply the bottom by a 7 under the radical, we have to multiply the top by a 7, but it also has to be under the radical. If we just put a 7 on top, but put a 7 underneath the square root on bottom, that's not equivalent to 1. 7 and the square root of 7 are not the same amount. So if we're not multiplying by 1, it changes how much we have. So we can't do that. So if this 7 is under the radical, so does that one have to be. So if we have the same factor twice under a square root, we can pull that out. So that gives us a 7 on bottom. On top, we have 2 square roots of 7. These don't cancel because one's under the radical, one's not. We don't have a square root left on bottom, and that's as far as we can go. So essentially, we made the denominator a perfect square. Another way of looking at this denominator is 7 times 7 is 49. The square root of 49 is 7. So now we don't have a square root left on bottom. All right, how about this one? So we can break this into 2 separate square roots. We can take the square root of the top over the square root of the bottom. We want to make the square root on bottom go away, and the way we do that is we make the bottom a perfect square. So every factor that we have on bottom has to occur twice. We only have one 13 on bottom, so we put another 13 on bottom under the radical, and to keep our fraction equivalent, we put a 13 on top. Anytime we're multiplying a fraction and we keep it equivalent, we multiply the top and bottom by the same thing. So on top, 1 times 13 is 13. On bottom, we could either multiply those together and make 169 and then take the square root of that, or we could say we have the same factor twice, so it comes out. Either way, we get 13 because the square root of 169 is 13. So we're making the denominator, we're making every number in the denominator, or when we get to letters, every letter in the denominator part of a group. So if it's a square root, our groups have size of 2. So let's look at this one. This time we're taking a cube root, so we're looking for groups of size 3. We only have one 3 under the radical, so we have to have 2 more. Now we have a full group of 3 3s. Of course, if we pick up 2 3s under the cube root on bottom, we have to pick up 2 3s under a cube root on top. 9 under the cube root there, 9 under the cube root there, so we picked up the same amount. Since we have a group of 3 on bottom, we pull that number out, and now we're no longer left with a radical on bottom. On top, we have a 5 on the outside, and on the inside, we have the cube root of 9. And again, remember, these don't cancel because this is under the radical, that's not. If you're still unsure why did we pull this out, we have 1, 2, 3 3s, so we have 3 to the 3rd power under a cube root. If we have a 3rd power and a cube root, those cancel. So we get that number out. All right, let's take a look at this one. Now, the previous examples we worked, the number on bottom was it was prime. But 18 is not prime, so let's look at what factors make up 18. 18 is 2 times 9. 9 is a perfect square, but 2 is not. So we could leave 9 as 9, or we could break 9 down as 3 times 3. So those are the factors that make 18. So under the square root on bottom, we have a 2, we have a 3, we have a 3, and then we have an x. And on top, we have a 5 under the radical. So we want to make the denominator a perfect square so that when we take the square root, everything comes outside. So we only have 1 2, so we need to pick up another 2 to go with it to make that group complete. So if we pick up a 2 on bottom, we have to pick up a 2 on top. The group of 3's is complete. We have 2 3's under a square root, so that's a full group. So we don't have to add or pick up any more 3's on top. But notice we only have one x. To get the x's out, we have to have a pair. So we pick up another x. Now we have a pair of x's, so we can pull them out. If we pick up an x on bottom, we have to pick up an x on top. So let's look at the bottom first. We have a pair of 2's, so we bring out a 2. We have a pair of 3's, so we bring out a 3. We have a pair of x's, so we bring out an x. All of this stuff is multiplied together, so when we pull those out, they're still multiplied. So on bottom, we end up with 2 times 3, so 6 times x. On top, we had 5 times 2, which is 10, times x. So the square root of 10x on top. And again, be careful that you don't try to cancel anything here, because everything on top is under a radical, everything on bottom is not. So we rationalize the denominator because we made the square root on bottom go away. Okay? Let's do this one. Let's write this as the cube root of 7 over the cube root of 2. Again, we're trying to make the square root on bottom, or in this case, the cube root on bottom, go away. 2 doesn't break down any farther. We have 1, 2. If we're making a perfect cube, we need 3 of them. So if we have 1, how many more do we need to make 3? We need 2 more. If we pick up 2 on bottom, we also need to pick up 2 on top. So on bottom, we have 2 3 times under the cube root, so the 2 comes out. On top, we only have 2 2's, so they don't come out. We only have 1 7, so it doesn't come out. So we have 7 times 2, that's 14, times 2 is 28. So we've made the square or the cube root on bottom go away. All right, this one's a little bit bigger. We have a fourth root instead of a square root or a cube root. So 4 is 2 times 2. So we need to look at what additional factors do we need in the denominator so that this is a perfect fourth root. And to be a perfect fourth root, for a factor to come out, we have to have that factor 4 times so that those cancel. We only have 2 2's. If we need a group of 4, we need 2 more. So now we have 1, 2, 3, 4 2's. So we have to get 2 2's up here. We only have 1 x, but we're trying to make 4. So if we only have 1, we need 3 more. So we have to get 3 on top. So if you want to rewrite this, you can. On bottom, let's put the 2's together. We have 1, 2, 3, 4 2's. So you could write all 4 of them, or you could write it like this. And our x's, we have 1, 2, 3, 4 x's. So you could write all 4 of them, or you could write it like that. So when we simplify that, when we take the fourth root of 2 to the fourth, the 4's cancel, leaving us just 2. Because we have 1, 2, 3, we have a group of 2's under the radical, so a 2 comes out. When we take the fourth root of this one, the 4 and the 4 cancel, leaving us an x out from underneath the radical, because now we have a group of x's. So we can pull an x out. Now on top we have 3 times 2, that's 6, times 2 is 12. 1, 2, 3 x's, so x to the third and a y. None of those factors occur 4 times, so nothing on top comes out. So all of that stuff is left under the radical. So we made everything on bottom a group of 4 because we had a fourth root. All right, the other type in this section deals with rationalizing denominators when we have 2 terms, when we have things added or subtracted. And if you watch the other video, then you picked up on that the way we make a binomial that contains a square root go away in the denominator is we multiply by its conjugate. The conjugate of 2 minus the square root of 7 would be 2 plus the square root of 7. So we multiply top and bottom by 2 plus the square root of 7. Now on top, we could distribute that or we could leave it factored. If we distribute it, it's not really going to simplify any, so on top, let's just leave that as 6 times 2 plus the square root of 7. On bottom, we need to multiply it out. So we're doing 2 minus the square root of 7 times 2 plus the square root of 7. And something really useful is going to happen when we distribute. We're going to get 2 times 2, so that's 4. 2 times the square root, so 2 square roots of 7. Minus the square root of 7 times 2, a negative times a positive is negative. 2 times the square root of 7 is 2 square roots of 7. Remember, don't do the 2 times the 7 because this is under the radical, that's not. And then when we multiply here, a negative times a positive is a negative. Square root of 7 times the square root of 7 is the square root of 7 times 7, or 49. So on top, we can continue to leave it alone. On bottom, notice the 2 middle terms. 2 square roots of 7 minus 2 square roots of 7, those cancel. 2 minus 2 makes a 0. On the end, the square root of 49 is 7. So we're left with 4 minus 7. Well, 4 minus 7 is negative 3. And this is the reason that I said not to multiply the top out. It was not going to simplify any when we multiplied it out, since we only have one term in this factor. And in order to reduce fractions, we have to have factors. So 3 is a factor because it's not being added with anything. So is 6. It's being multiplied times something. So 3 goes into 3 once. 3 goes into 6 twice. And we could leave the negative on bottom, or we could put the negative out front and call this 2 times 2 plus the square root of 7 over 1. Or if it's over 1, we don't have to write the 1 on bottom. Anything divided by 1 is itself. So the key here is multiplying by the conjugate. And this will always work, that when you multiply by the conjugate, the square root on bottom will go away. So let's do one more. We have another one that we want to make the square roots on bottom go away. So the conjugate of the denominator here would be the square root of x plus the square root of 2. We keep the same terms, we just change the middle sign. We change it from a minus to a positive. If it was positive, we would have a minus. We just need these to be opposite signs. So we're going to multiply the top by the same thing so that our fraction is equivalent. We're just multiplying by 1, so it doesn't change how much we have, it just rewrites it. So on top, nothing will really benefit us by multiplying the top out. So we're just going to leave it factored. And then we're going to multiply the bottom out, because when we multiply the bottom out, it will simplify. So we're going to do this times that. We can look at this several ways. When we multiply these together, we have x times x, which is x squared. And when we have an x squared under the radical, the square root and the squared cancel. You could also say, look, we're multiplying this times itself. And if we multiply something times itself, it's squared. Either way, a square root and a square cancel, leaving us x. So here, when we multiply these, square root of x times square root of 2, that's the square root of 2x. We multiply x times 2 and get 2x. When we distribute here, a negative times a positive is negative. Square root of 2 times the square root of x is square root of 2x, just 2 times x. And then when we distribute here, negative times positive is negative. Square root of 2 times square root of 2, well, 2 times 2 is 4, so that makes 2. So on top, 5 times the square root of x plus the square root of 2. On bottom, the middle terms cancel because they're opposites, and we're left with x minus 2. That whole thing is one factor, and we don't have that factor anywhere else, so that doesn't reduce any. So that's as far as we can go. So I hope these problems helped to kind of make sense of some of the things that we covered in this section.